Good morning, 4th grade. Today's lesson for Friday, May 1st is on using area models and partial products to solve double-digit multiplication problems. Now, we've done this in class. I understand most of you prefer this method of multiplication, but I am going to reteach it today to try to show just a reminder, but also to show maybe your parents, if they don't understand the area model, I'm going to do my best to explain how that works or why it works. So here's our problem we're going to look at, which is 13 times 18. Now there's a few things I want to point out before I start working through this problem. 13 is made up of two numbers, right? It's made up of a 10 and it's made up of a 3. Now if I were to draw out 13 or model it, it would look like that, right? But either way, it is made of a 10 and a 3. And 18 is made up of a 10 and an 8. And if we were to draw that out, we would have our 10 and then 8 ones. So that's what 18 would look like. Now this is important because when we multiply these numbers together, 13 and 18, we're actually going to multiply the 10 times the 10 and the 8, the 3 times the 10 and the 8. But we've always learned here in the U.S. especially just to stack them up, multiply them together, and we don't really understand the math that's going on. All we do is we just know we do, this to this, this to this. Move over a place, add a 0. That to that, that to that. We have these really, I don't know, it's just mechanical understanding, right? Like step 1, step 2. We don't understand the math behind it. And what this attempts to do is to explain to kids why we're doing what we're doing. And it is a way better strategy. So let's take a look now at this thing that we use. It's called an area model. And all it is a rectangle, right? It says it's a model and all this other stuff, and it makes it sound way more difficult than it actually is. What we're going to do is each one of these boxes is a location where we're going to carry out a very specific multiplication fact. That's it. That's all these boxes are. It's a workspace to do our multiplication. So I'm going to take this 13 and I'm going to split it into its tens place and its ones place, just like I showed you here. And I'm going to write those numbers off to the side. So my 10 is going to go here, kind of like in this row. And my 3 is going to go down here in this row. Now I'm going to do the same thing for the 18. I'm going to put the 18 across the top. So remember, an 18 is made up of a 10 and an 8. So the 10 exists in this column. And the 8 will exist right here. Now here's where it gets, I'm not going to say it's tricky, because I don't feel like this is tricky or anything like that. And all these markers are getting beat up. Use a pen. So let's imagine that this 10 right here is sending out kind of like a line, okay? And so is the 3. So I'm just going to draw these kind of light so you can kind of get a visual. All right. Now the 10, let's imagine that 10 is also kind of sending out a directional arrow, right? And it's kind of moving through these boxes. Okay, well, let's follow the path of this 10. And it intersects right here. Do you see where this 10 and this 10 intersect right there? Well, that's the multiplication fact we're going to work out in this box. We're going to multiply 10 times 10. Now let's follow this 10 across. The 10 travels all the way over to this point in time, right? Here's the 10. What does it intersect with? Well, it's intersecting with the 8. So you have a 10 times an 8. Now over here we're going to do the same thing with the 3. Follow the 3 across. What does the 3 intersect with? Well, it intersects with the 10. So inside of this box we're going to solve for 3 times 10. And over here we're going to solve for 3 times 8. You can see the 8 travels down, they intersect at that point. Now, we're not going to draw these arrows every time, we're not going to draw the zeros. This is just to illustrate what's happening inside of these boxes, okay? Now, in the past, we've been talking about how to multiply by tens or how to multiply double-digit numbers and made it very simple. And the reason we focus so heavily on doing that is for this specific purpose. If you look at all of these facts, they're pretty simple multiplication facts. They really are. In this box, for example, 10 times 10. that's a very easy multiplication fact. It's 10 groups of 10, or you could do 1 times 1, which is 1, and add the 2 zeros showing that they were 10s. There's lots of different ways we could solve this, but the easiest way is just memorizing our multiplication facts, which a lot of parents are not asking their children to do. That's something parents need to do. My father taught me. I think your parents probably pushed you to learn it as well. But 10 times 10 is 100, right? So we've solved one part so far out of the 4 needed to come up with an answer. Next up is 10 times 8. Again, just very simple multiplication fact, especially if we've taken the time to memorize them. 10 times 8 is going to be 80. Over here we have a 3 times 10. If it makes you more comfortable, you can also view 3 times 10 as 10 times 3. Forward and backwards, same thing. 10 times 3 or 3 times 10 is 30. And lastly, 3 times 8, right there. 3 times 8 is 24. All right, so what do I do with all these numbers now? Well, I'm going to add them up. I'm going to take the 100 and the 80, and I'm going to stack them, just like that. And then I'm going to take my 30 and my 24. I'm going to stack them up. I'm going to add all this stuff, because in total, right, all 4 of these parts tell me what 13 times 18 is. So let's add this up. 0, 0, 0, and 4. It's going to be 4. We have a 0 and 8, a 3 and a 2. I spotted a 10 pair, 4th graders. 8 plus 2 is 10. 10 plus 3 is 13. So write the 3, carry the 1. And again, I am making a lot of misstatements here. That is not actually a 3, it's a 30. It's not a 1, it's a 100. But we're moving fast here, right? So 1 plus 1 is 2. And that's it. The answer is 234. There's your answer. Now, let's take this back to a traditional method of multiplication, just so we can try to relate what we grew up understanding with what's happening here. All right, so first up, my very first multiplication fact is going to be 8 times 3. You know that, right? Okay, well, check it out. We did 8 times 3 right there. But here when I multiply 8 times 3, I have to do kind of this weird stuff where I say 8 times 3 is 24. Okay, write the 4 and carry the 2. So we've lost sight of the fact that 8 times 3 is 24, and now we're just viewing it as a 4, and then we're carrying a 2, and that's not even a 2, right? That's a 20. So the next multiplication fact I have to complete is this one, 8 times 1. And the thing is that's not a 1. We should all know that by now. That's a 10. Well, we already did 8 times 10. It's right there. So 8 times 10 is 80. So here 8 times 1 is 8, plus 2 more is 100, right? But I have to say this simply. 8 times 1 is 8, plus 2 is 10. Let's write the 10. All right, so it's 10. All right, so 104. Well, check it out. If I would have added up, remember, I multiplied 8 times 3 and 8 times 10. I multiplied 8 times 3 and 8 times 10. Well, when I add those two together, it's 104. And that's actually the first amount I'm going to get in my first level of multiplication, when I multiply the ones place times my 13. All right, next up, I have to move over to the 1 here, which means I add a 0. Okay, well, that's just a step that we memorized as kids but never understood. No one can ever tell you why you're adding that 0 there. I mean, ask yourself, do you know why you add the 0? And most adults will answer, no, I don't. I just do it because that's what you're supposed to do. And that's fine, but it's always better to understand why we're doing stuff than just to blindly follow. So we're adding that 0 because that's not a 1, it's actually a 10. That's a 10 and an 8. Since we're multiplying by this 1, and that's all we're going to multiply by, we leave the 0 here to show that we were multiplying by 10. All right, so here we're going to multiply 1 times 3. But that's not really a 1. It's a 10 times a 3, which you can see we've multiplied by right there. So 1 times 3 is 3. We're going to write our 3 down here. Next up, 1 times 1. Okay, but this is not a 1 times a 1. That's absolutely false. This is a 10, and that's a 10. So we're going to multiply 10 times 10, which we've already done up here, right? 10 times 10. Anyhow, 1 times 1 is 1. We add all that up. 4 plus 0 is 4, 0 plus 3 is 3, and 1 plus 1 is 2. We come up with the same answer of 234 that we did here. Now I want to go back to a second to these gray multiplication facts I wrote out. 10 times 3 and 10 times 10. You can see them both right here, right? 10 times 3 and 10 times 10. If we added those together, we'd get 130, which is exactly what we got in this level of multiplication. So let's see, connection, I guess, or the similarities between the two. It's not even a similarity; they're exactly the same. Doing it with the area model and doing it with traditional algorithm are identical, but the thing is there's a ton of steps that go on in this traditional algorithm where we're adding zeros and we're calling stuff twos and ones and ones. It's really mathematically unsound, and it's not a good idea to learn in that way. This method right here is incredibly fast for simple multiplication, and it's the best possible way to start with children who are just learning multiplication. As an adult, we would not use this anymore. We wouldn't. But we've also been doing multiplication for 20 years, right? So there's no reason for us to be using an area model, whereas your children have been doing area models they've been working with multiplication for a year. So we give them this so they better understand the math. If you don't understand this, and this is all you can do with your child, that's good enough. However, don't send a message to your children that the area model is foolish or pointless and it's not worth your time. It's absolutely worth your time, and I can guarantee that through my use of this, I have a much better understanding of multiplication than I used to when I just did this. Kids, if you have any questions about area models, partial products, any of that stuff, please ask away on Dojo. I'll be happy to help.